Math 1143, Test 3 review sheet over the Chapter 3 material. Section 3.1 is on inverse functions. In number 1, we show that each function is or is not a one-to-one function. So if you'll recall, if f of a equals f of b implies that a equals b, then f is a one-to-one function. That's the analytic test. So we'll try that with this one. F of x is equal to x plus 5 divided by x minus 3. And so if we set f of a equal to f of b, that means a plus 5 over a minus 3 equals b plus 5 over b minus 3. Then we'll use the fact that when a fraction equals another fraction, their cross products are equal. One cross product is a plus 5 times b minus 3. We set that equal to the other cross product, a minus 3 times b plus 5. And then multiply the two binomials on the left-hand side. We get a times b minus 3a plus 5b minus 15. Multiply the two binomials on the right-hand side. We get a times b plus 5a minus 3b minus 15. If we add 15 to both sides, those numbers are eliminated. If we subtract a times b from both sides, the ab terms are eliminated. And then we're left with negative 3a plus 5b equals 5a minus 3b. So we can do a couple of things. I'll subtract 5a from both sides and also subtract 5b from both sides. And when we do that, we get negative 8a equals negative 8b. And then divide both sides by negative 8. We get a equals b. So f of a equals f of b implies a equals b. So that shows that this function is a one-to-one function. So I'll just write here f is one-to-one. Hey, in the next example, g of x equals x squared plus 2. So if we start out by writing g of a equals g of b, g of a is a squared plus 2, g of b is b squared plus 2, and then if we subtract 2 from both sides, we get a squared equals b squared. And then if we solve for a using the square root property, we get a equals positive and negative square root of b squared, or a is equal to positive and negative b. So this shows that even though g of a equals g of b when a equals b, it's also the case that g of a equals g of b when a is equal to the negative of b. You can do a specific example. We can note that g of 2 equals g of negative 2, because g of 2 is 2 to the second plus 2. G of negative 2 is the number negative 2 squared plus 2. Do the arithmetic. 2 to the square, 2 squared plus 2 is 4 plus 2 or 6. Negative 2 squared is 4. 4 plus 2 is 6. But 2 does not equal negative 2. So in this function, in this example, g is not a one-to-one function. So that means its graph in the xy plane fails the horizontal line test. And we know that already. This is just the function of a particular parabola. Okay, this one, k of x equals x minus 4 to the third plus 2. So we'll do the same test. Set k of a equal to k of b. K of a is the quantity a minus 4 cubed plus 2. And we set that equal to k of b, which is b minus 4 cubed plus 2. Then subtract 2 from both sides. We get a minus 4 to the third equals b minus 4 to the third. Then compute the cubed root of both sides, and we get a minus 4 equals b minus 4. And then add 4 to both sides, and we get a equals b. So k of a equals k of b implies a equals b. So that means this function k is a one-to-one function. Its graph in the xy plane passes the horizontal line test. Okay, the next sheet, number 2, determine if f of x equals 3x plus 2 and g of x equals 1/3 x minus 1 are inverse functions of each other. Well, one way to do it is to compose f and g, f of g of x. If f and g are inverses, then f of g of x equals x, and so does g of f of x equal x. So f of g of x is equal to 3 times 1/3 x minus 1 plus 2. Do the arithmetic. 3 times 1/3 x is x, and minus 3 times 1 is minus 3, and then plus 2, we get x minus 1. Since x minus 1 is not x, we don't need to do anything more. We conclude that f and g are not inverses. As soon as you get one condition that fails, then you don't have to do any more work. F and g are not inverses. Okay, in number 3, part A, find the inverse functions and the domains and ranges. This is a rational function. Note that the denominator is x plus 2. So that means the domain consists of every real number except negative 2. Negative 2 is the number that makes the denominator 0. And so it's a restricted value. So the domain of f is from negative infinity to negative 2, parenthesis, union, parenthesis, negative 2 to infinity. Okay, then to find the inverse of f of x, replace f of x with y, so we get y equals x minus 5 over x plus 2. Then interchange x and y, so we get x equals y minus 5 over y plus 2. And then we proceed to solve this equation for y, and when we're finished, y will be equal to the inverse. So multiply both sides by the least common denominator, y plus 2. So we get x times y plus 2 equals y minus 5. And then I'll continue up here, xy plus 2x equals y minus 5. And then in the next step, I'll subtract y from both sides and also subtract 2x from both sides. So we get xy minus y equals negative 2x minus 5. And then factor y out. We get y times x minus 1 equals negative 2x minus 5. And then divide both sides by x minus 1. We get y equals negative 2x minus 5 divided by x minus 1. So the domain of the inverse, this is f inverse. The domain of f inverse is every real number except positive 1. So one thing to remember, the domain of f inverse is the same as the range of f. So the range of f is every real number except 1. So negative infinity to 1, parenthesis, union, parenthesis 1 to infinity. And so the range of f inverse is the same as the domain of f. So since I'm running out of space here, I'll just leave it at that. Move on to the next example. G of x equals the square root of x minus 3. To find the domain of this function, well, we want real valued functions, so we want to take the square root of non-negative numbers. So that means x minus 3 has to be greater than or equal to 0, or x is greater than or equal to 3. So the domain of the function g is from 3 to infinity, including 3, and the range, well, the smallest range value is 0, and then after that they're positive. So the range is all of the non-negative numbers from 0 to infinity. Okay, to find the inverse, replace g of x with y, so we get y equals the square root of x minus 3. Then interchange x and y, we get x equals the square root of y minus 3. Then we solve for y, so we square both sides. We get x squared equals y minus 3. And then add 3 to both sides. We can write it as y equals x squared plus 3. And that's what g inverse is. G inverse of x is x squared plus 3. But the domain of g inverse is the same as the range of g, that's from 0 to infinity, and the range of g inverse is the same as the domain of g, which is from 3 to infinity. Okay, so one thing to be aware, this function, if this were by itself, y equals x squared plus 3, then the graph would be a full parabola in the xy plane. But this is the formula for the inverse of g, and its domain is restricted to only those x values from 0 to infinity. So just a rough sketch of what this g inverse equals x squared plus 3 looks like. The y-intercept is 0, 3. And then it's just a half of a parabola. This is not a very good graph, but it's just the right half of the parabola because the domain is from 0 to infinity. Okay, the next function, r of x. Well, this is a linear function, and it has a non-zero slope. And so, well, we know the domain is all real numbers, and so is the range. The domain is from negative infinity to positive infinity, and the range is also from negative infinity to positive infinity. And we also know that it's a one-to-one function. The graph in the xy plane passes the horizontal line test. Okay, but to find the inverse, replace r of x with y, so we get y equals negative 2/3 x plus 4. Then in the next step, replace y with x and replace x with y, so we get x equals negative 2/3 y plus 4. And then solve this equation for y. So first we'll subtract 4 from both sides. X minus 4 equals negative 2/3 y. And then multiply both sides by the reciprocal of negative 2/3. So multiply both sides by negative 3/2. So negative 3/2 times the quantity x minus 4. And then negative 3/2 times negative 2/3 y is just y. And then we'll write this as r inverse of x, and we'll do a little bit more arithmetic. Negative 3/2 times x is negative 3/2 x. And negative 3/2 times negative 4 is positive 12/2, or positive 6. So r inverse is negative 3/2 x plus 6. Its domain is all real numbers, and so is its range, all real numbers.